Imagine a place where the laws of physics break down. A place so extreme that even light, the fastest thing in the universe, cannot escape. If you fell into this place, time itself would slow down for you while the rest of the universe aged billions of years in the blink of an eye. Sounds like science fiction? Well, it's not. This is the mysterious world of black holes, the most enigmatic and terrifying objects in the cosmos. For centuries, humans have gazed at the night sky, wondering what lies beyond. We once believed that space was an endless, peaceful expanse. But black holes shattered that illusion. These celestial beasts lurk in the darkness, swallowing everything that comes too close, warping space and time itself. What are they? Where do they come from? And could one be lurking closer than we think? To truly understand black holes, we need to go back in time, to an era when the very idea of such a thing seemed absurd. It all started with a simple question. What happens when a star dies? The birth of a black hole. Stars are not eternal. They are born, they live, and eventually they die. But not all stars meet the same fate. Small stars like our Sun will quietly fade into white dwarfs. But massive stars, those at least 20 times the mass of our Sun, face a much more violent end. When a massive star runs out of fuel, it can no longer generate the nuclear reactions that keep it stable. Gravity, the force that was once balanced by the star's internal pressure, suddenly takes over. In an instant, the star collapses in on itself, triggering a supernova, one of the most powerful explosions in the universe. What's left behind depends on the star's size. Some become neutron stars, but the most massive ones collapse even further, forming a region of space where gravity is so intense that nothing can escape. This is a black hole. At the heart of a black hole lies something called the singularity, a point of infinite density where all the mass is concentrated. Around it is the event horizon, the point of no return. If you cross this invisible boundary, there's no coming back. Not even light can escape. This is why black holes appear completely black. But here's where things get even stranger. Black holes and the warping of space-time. To understand black holes, we have to rethink how we see the universe. We tend to think of space as an empty, flat stage where planets and stars move around. But Einstein's theory of general relativity changed that forever. Space is not just an empty void. It's like a flexible fabric called space-time, which can bend and stretch. Imagine placing a bowling ball on a trampoline. The ball creates a dent, causing smaller objects to roll toward it. This is how gravity works. Massive objects curve space-time, pulling smaller ones toward them. Now imagine dropping something so heavy onto the trampoline that it tears a hole through it. That's what a black hole does. It doesn't just bend space-time, it punches a hole in it. This warping of space-time leads to bizarre effects. If you watch someone falling into a black hole, they would appear to slow down, their movements stretching, their light turning red, until eventually they freeze at the edge of the event horizon. But for the person falling in, time would feel completely normal until they reach the singularity, where the laws of physics break down entirely. What's inside a black hole? Here's where science meets mystery. We have no idea what truly lies at the center of a black hole. The singularity is a place where our understanding of physics collapses. Some theories suggest that all matter is crushed into an infinitely small point. But quantum mechanics hints at something else. Could the singularity be a gateway, a portal to another universe? Or does space-time itself end here? Physicists like Stephen Hawking believed that black holes might not be completely inescapable. In 1974, he proposed that black holes slowly evaporate over time due to a strange quantum effect known as Hawking radiation. If true, this means that even the most fearsome black holes are not eternal. They might eventually disappear, leaving behind nothing but empty space. But before we talk about black holes dying, what if some black holes have been alive since the birth of the universe? Primordial black holes, ancient cosmic relics. Most black holes are born from dying stars, but what if some have existed since the very beginning of the universe? Enter primordial black holes, hypothetical cosmic entities that might have formed just fractions of a second after the Big Bang. Scientists believe that, in the chaotic early universe, tiny regions of space may have been so dense that they collapsed under their own gravity, forming black holes no bigger than an atom. But don't let their size fool you. A primordial black hole the size of a marble would have the mass of an entire mountain. Some theories suggest these ancient black holes could still be floating through space today, invisible and undetectable, unless they collide with something. Could they explain dark matter, the mysterious substance that makes up most of the universe's mass? Or even more chilling, could one be lurking in our solar system right now? A black hole in our solar system. It sounds like something out of science fiction, but some scientists have speculated that a black hole might be hiding in the outer reaches of our solar system. For years, astronomers have noticed strange gravitational effects beyond Neptune, suggesting the presence of an unknown Planet 9, a massive object pulling at distant celestial bodies. But what if Planet 9 isn't a planet at all? What if it's a tiny black hole barely the size of a grapefruit, but containing 10 times the mass of Earth? While there's no direct evidence yet, astronomers are actively searching for signs. If a black hole were truly lurking at the edge of our solar system, it wouldn't pose a threat to us, at least for now. But what about black holes that do wander through the galaxy? Could Earth ever be swallowed by one? Could a black hole destroy Earth? The short answer? Unlikely, but not impossible. The closest known black hole to Earth, Gaia BH1, is about 1,500 light-years away, far enough that we're safe. But the universe is vast, and rogue black holes that have been ejected from their galaxies, are real. These cosmic wanderers drift through space, completely invisible, until something crosses their path. If a rogue black hole were heading toward us, we wouldn't see it coming until it was too late. But before you panic, black holes are actually tiny targets in the vastness of space. The odds of one colliding with Earth are so low that it might never happen in the entire lifetime of the universe. However, black holes don't need to swallow Earth to cause destruction. If one passed too close, its immense gravity could disrupt our orbit, causing catastrophic climate shifts or even tearing our planet apart. While this is highly unlikely, black holes do shape galaxies in more subtle ways. In fact, they might be the key to why galaxies even exist. The supermassive giants at the heart of galaxies. Not all black holes are the size of stars. Some are millions or even billions of times more massive than our Sun. These are supermassive black holes, and they sit at the heart of almost every galaxy, including our own, the Milky Way. Our galaxy's central black hole, Sagittarius A, has the mass of 4 million suns. But here's the paradox. While black holes are often seen as destroyers, they may actually be creators as well. Supermassive black holes influence the formation of stars, shape galaxies, and even trigger the birth of new solar systems. Without them, the universe might look completely different. But how do black holes grow so big? Do they merge with other black holes? Do they devour entire stars? Or could there be something even stranger happening inside them? The secret within. What lies beyond the event horizon? A black hole's event horizon is the point of no return, the invisible boundary, where gravity becomes so intense that not even light can escape. But what happens inside? Do objects get crushed into nothingness? Do they enter another universe, or does something even stranger occur? Scientists believe that at the heart of every black hole lies a singularity, a point where gravity becomes infinite and the laws of physics as we know them completely break down. Time and space cease to exist in any way we can comprehend. This singularity is the ultimate cosmic mystery, one that no human or even a photon of light could ever return from to tell the tale. But here's where things get truly mind-bending. Some physicists believe singularities might not even exist. Instead, there could be a hidden layer of reality, beyond the event horizon, one that we simply don't have the science to understand yet. Could black holes be more than just cosmic traps? Could they be gateways to another place entirely? Are black holes wormholes? The idea that black holes might be wormholes, shortcuts through space and time, is one of the most fascinating theories in modern physics. The equations of Einstein's general relativity actually allow for such a possibility, but there's a catch. If black holes were wormholes, they would need something called exotic matter, a theoretical substance with negative energy, to keep the passage open. Without it, the wormhole would collapse the moment anything tried to pass through. But if wormholes did exist inside black holes, where would they lead? To another galaxy? Another universe? Or could they connect different points in time? Some researchers suggest that black holes might actually be time machines, natural tunnels that could, in theory, allow for time travel. Of course, we don't have any direct evidence for this, but the idea raises an even deeper question. What if black holes don't just swallow information, but store it? The black hole information paradox. Do black holes erase reality? One of the biggest mysteries in physics is whether black holes destroy information. According to quantum mechanics, information can never be truly lost. It can be transformed but not erased. But black holes seem to do just that. Anything that falls in appears to be gone forever. This contradiction is known as the black hole information paradox, and it has puzzled scientists for decades. Stephen Hawking once proposed that black holes might slowly leak information back into the universe through a mysterious process called Hawking radiation. This would mean that over trillions of years, a black hole would eventually evaporate, leaving behind nothing but a faint whisper of the information it once consumed. But what if black holes don't just delete information? What if they store it somewhere else? Some scientists propose that black holes might function like cosmic hard drives, preserving the information of everything they consume in a hidden form. Others believe that the information might be imprinted on the event horizon itself, a strange, holographic projection of everything that has ever fallen in. And then there's an even wilder possibility. Are we living inside a black hole? Some physicists have proposed a radical theory. Our entire universe might be inside a black hole. The reasoning? The Big Bang, the moment our universe was born, shares strange similarities with the physics of a black hole. Some suggest that our universe began inside the event horizon of a much larger black hole, one that exists in another, higher dimensional space. If this were true, then every galaxy, every star, and even you and me would be part of an unimaginably vast black hole's interior. This idea, while speculative, hints at a deeper truth. Black holes might not just be objects in the universe. They might be a fundamental part of how the universe itself works. But perhaps the greatest mystery of all is, what happens when a black hole dies? Does it simply vanish? Or does it create something new? The death of a black hole, a new beginning. Black holes are the ultimate cosmic devourers, swallowing stars, bending time, and hiding secrets beyond human understanding. But what happens when a black hole itself dies? Does it simply disappear into nothingness, leaving behind an empty void? Or could its death be the birth of something entirely new? Stephen Hawking proposed that black holes aren't truly eternal. Through a process called Hawking radiation, they slowly lose energy over time. This happens because quantum fluctuations at the event horizon produce pairs of virtual particles. One falls in, while the other escapes, stealing a tiny fraction of the black hole's mass. Over trillions upon trillions of years, a black hole gradually shrinks, until in its final moments it releases an enormous burst of energy in one last spectacular explosion. But here's where things get really strange. Some scientists believe that when a black hole dies, it could create a new universe. The idea comes from the fact that the laws of physics as we know them break down at the singularity. If space and time are ripped apart inside, what if the singularity isn't just a dead end, but a gateway? Some propose that when a black hole collapses, it could trigger a new Big Bang, forming an entirely separate universe. This raises a profound question. Could our own universe have been born from a black hole in another cosmos? If so, black holes aren't just destructive. They're cosmic seeds giving birth to new realities beyond our own. Black holes, the architects of the universe? Far from being just monstrous voids that consume everything, black holes may play a fundamental role in shaping the universe. Every large galaxy, including our own Milky Way, has a supermassive black hole at its center. Without them, galaxies might never have formed in the first place. The immense gravitational pull of these behemoths controls the motion of billions of stars, shaping the structure of entire galaxies. Some researchers even believe that black holes regulate star formation, deciding how and when new stars are born. In a way, black holes aren't just destroyers, they're also creators, sculpting the cosmos in ways we are only beginning to understand. But perhaps the most astonishing revelation is that black holes might hold the key to unifying all of physics. They challenge everything we know: gravity, quantum mechanics, even the nature of space and time itself. Cracking the mystery of black holes might not just reveal their secrets, but the secrets of reality itself. The final question. What? Are black holes hiding? After everything we've explored, and one question remains: what are black holes really hiding? Are they cosmic tombs, erasing everything they consume? Or are they gateways to other universes, to the future, to the unknown? Are they the final fate of dying stars, or the beginning of something greater? The truth is, black holes remain one of the biggest unsolved mysteries in science. Every new discovery leads to more questions, and every answer reveals something even stranger than before. Perhaps one day we'll find a way to uncover the truth, whether by sending probes to study them up close, or by unlocking the ultimate theory of everything. But until then, one thing is certain: the secret life of black holes is far from over.